Hello student, in the second unit of Elements of Industrial Automation, we are going to discuss the PLC, that is Programmable Logic Controller. So what are the unit outcomes? After completion of this unit, you should be able to describe with sketch the function of the given part of PLC. So we are going to discuss the various parts of PLC. Then you should be able to describe the function of specified path of the given discrete IO module. IO means your input output module. You should be able to describe the function of specified path of a given analog input output module. Describe the function of specific part of given special IO module. Compare the salient features of the given PLC using block diagram. Now what is a programmable logic controller? A programmable logic controller is an industrial grade computer that is capable of being programmed to perform control function. The programmable controller has eliminated much of the hardwiring associated with the conventional relay control circuit. Other benefits includes easy programming and installation, high control speed, network compatibility, troubleshooting and testing convenience, and high quality. Early, we are going to use the hardwire relay logic for controlling purpose or doing the automation of the machine. But when you are going to use the hardwire relay logic, at that time it is quite difficult for you to just make changes in the system. Say if you are going to manufacture a particular model, then if there are certain changes in the model, you need to rewire the panel, and when you are going to rewire, there are hundreds of relays over there, so it is quite difficult and time consuming task to make the changes in that circuit. Okay, so that is the main problem. And as the in the initial days, the industrial automation is used in the automobile sector, and in automobile sector, after a particular period of time, new models will launch, so there are certain modification, and it is quite difficult for the industrialist to make changes in the system. Sometimes they have to replace the complete assembly line. Okay, and that takes a lot of time, so they are trying to find out some simple solution over that. Okay, so over the period of time, they will find out the device called as PLC. This is the programmable logic controller, in which the internal logic is going to be performed in the form of programming, and the most commonly used language for programming is your ladder logic program. The PLCs are come into the various sizes. So this is the commonly used for low input, less number of input outputs. These are called as the brick PLC, micro PLC, or mini PLC, and these are the modular PLC. So in the brick PLC, the controller input terminals, output terminal, or input module, output modules, controller, display, everything, memory is in the same unit. In case of modular PLC, your power supply is different, processor is different part, communication module is different, and it has expandable slot to which you can connect the number of input output devices. So this type of PLCs are used for large number of applications. Okay, where the input output requirement is large. Now, programmable logic controller is designed for multiple input and output arrangement, extended temperature ranges, immunity to electrical noise, and resistance to the vibration and impact. So basically, when you are going to hear the word PLC, as we have commonly used the PC for personal computer. So what is the basic difference between the PC and PLC? PLC and PC, the major difference is that PCs are designed for multitasking purpose. We can perform a number of functions over the PC, and they require certain conditions in which they are working properly. But industrial conditions are different. Industry have extended range of temperatures. There is a lot of electrical noise, vibrations. Okay, so if I'm going to use a PC over there, I cannot use the PC over there because that will affect the life of the PC. So instead of that, we have used a specially designed PC, that is a programmable logic controller, which is designed to perform a single task. It is simply sensing the input, process the data, and give you the output. The program for the control and operation of manufacturing process and equipment and machinery are typically stored in the battery bank or non-volatile memory. So in PLC, we are using the non-volatile memory, that is the ROM, for storing the program. Okay, or if it is the RAM memory, then in that case we are going to provide the battery backup. Okay, so that in case of the power failure, the program does not get lost. Okay, a PLC is an example of real-time system since the output of the system controlled by the PLC depends on the input condition. So PLC is normally an example of real time. Real time means what? At the same moment, what are the changes going on the input side that should be reflected on the outside output side. Okay, so if there is certain changes in the input condition, then that changes must be reflected in the output of the system. Initially, PLC was used to replace the relay logic, but it is capable not only of performing the relay switching task but also of performing the other applications such as timing, counting, calculating, comparing, and other processing of the analog signal. So, in the initial days of the PLC, as we have discussed, the PLCs are used to replace the relay logic. Okay, so when I'm going to implement the logic by using the relay, it require hundreds and thousands of relay that will make a wiring very complicated, and it is quite difficult for you to make changes in that system. So to simplify that, we have come with the programmable logic controller. Okay, so in programmable logic controller, what you are going to do, we are replacing the relay logic with the help of programmable logic. Okay, and for that purpose we are commonly using the language that is called as the ladder long language. There are so other languages also, but all over the world most commonly used language is the ladder long language. And but what happened over the period of time, the PLC does not only replace the language relay logic, it will perform relay switching tasks. Okay, and other applications such as timing. So if I want to start certain system after 10 minutes, 10 hours, or whatever, so we can just use the timing from millisecond, microsecond to few hours also, few days, few months also. So that timing function is there. Counting function, if I want to count certain events, how much time that event is going to be trigger or something, that is also possible. Calculation purpose also I can use the PLC. Then comparing, if I want to compare the current temperature with the previous temperature or the system temperature with the set value, that is also possible. And if I have set the system at 25 degrees centigrade and my temperature increases to 30 degrees centigrade, so during that it will generate the alarm or disconnect the system. That is going to be happen with the help of comparable. And processing of the analog signal, PLC also used for processing analog as well as digital signal. In case of digital signal, basically we have only one value, either it may be 0 or it may be 1 at a time, but analog signals will vary over the period of time. Now programmable logic controllers. Why programmable logic controllers are used? So programmable logic controllers will give you the increased reliability, more flexibility, lower cost, communication capability, faster response time, and easier to troubleshoot. So this we are going to discuss in the